Hello, this is Mr. Stansbury. I'm going to take you through the chi-square goodness of fit notes. At the end of this, you should be able to say, I can perform a chi-square goodness of fit test to determine if a variable is likely to come from a specified distribution or not. Okay, what does this mean? Let's take a look. Okay, so we can use what we call a chi-square goodness of fit test to test hypotheses or a hypothesis about population proportions. So, example, we can test to see if a die is fair. So, does it fit within what we would expect for it to happen? And a die being fair, meaning like, if you rolled a six-sided die over and over again, you should get about 1/6 of the time you should get each one of the numbers. So if you get like 1 through 4, you get 1/6, but then on 5 you get like 1/5, and then on the last one you get like a different fraction. Then that's a little bit unfair. So that's what this chi-square goodness of fit test checks. It checks to see if things are what they should be. Okay, so first, here's the summary of the chi-squared goodness of fit. So they take us through the steps, like they like to give us all the steps to make this make a little bit more sense. And we're going to actually take these steps through an example, which will help it make even more sense. Okay, so just like normal, we're going to state the null hypothesis and alternative hypothesis, significance level, calculate the value of the test statistic. So that's the new thing. Oops, that is what we call chi-squared, or chi-square officially. Use technology to calculate the p-value, which we've done before, using DF, degrees of freedom, number of categories minus 1. That's something new that we'll talk about here in a second as well. And then reject HO, and then interpret your decision. So it's really kind of similar to what we've been doing all along in this unit. It's just got a few little changes, and we'll show you what this is used for. So here's our example. From 1970 to 2000, when given the choice of 3 highly popular albums to choose from, 27% of the people chose Wayne Cochran's Going Back to Miami. Beautiful hair. 31% chose Wally Whiten's It's Me Mum, and 42% chose Aunt Bertha's Family Favorites. Last week, 70 of Wayne's albums, 72 of Wally's, and 104 of Bertha's albums were purchased. Conduct a chi-square goodness of fit test with a 5% level of significance to determine whether there has been a change in the proportions of albums sold since 2000. Okay, so here's our steps. Name the null hypothesis and the alternative hypothesis. So remember, the null hypothesis, the HO, is always that everything is just how they say it's supposed to be, and that there's nothing is fishy. Meaning that all these percentages should be pretty close to with a reasonable amount of like what was purchased in the last week. Okay. So let's go with HO. Let's see. So we're going to write this. We're going to write HO is that the probability of, let's go with Wayne, should be 27, so 0.27. So really we should make this into a colon there. Probability of Wayne is 0.27. Probability, Wayne, let's see, WC, let's go, probability of Wally Wayton is going to be 31, 0.31, and the probability of Aunt Bertha is going to equal, wasn't she 42? There we go, 42, 0.42. Okay? So that's what we're expecting to happen. So it should be pretty close to that. Okay, so that means that our H1 is going to be that at least one of these is going to be off. So at least one of probability of Wayne Cochran, right? does not equal 0.27, or the probability of Wally Whiten, it does not equal 0.31, or the probability of Aunt Bertha does not equal 0.42. That's going to be our alternative hypothesis, meaning that it's not holding true to the original percents that we thought. Okay, state the significance level, 5% level of significance, so that is 0.05. Okay, calculate the value of the test statistic, chi-squared calculated. You can do this by hand, but for what we're going to do in here, we're just going to do it on the graphing calculator. I will give you links to places that will show you how to do this by hand, but you do not need to worry about that. We're going to do it on the graphing calculator. Okay. And then use technology to calculate the p-value, also on the graphing calculator, using DF. DF stands for, let's get this a good spot here. This is degrees of freedom, they call this. Okay. So as I understand that, that means this is going to be the number of values that are free to vary. Okay, so we can have a couple. In this case here, we have 3 different categories because there's 3 different albums here. So RDF. Oops, let's go back to blue here. RDF is going to equal 2 because we have 3 categories, subtract 1, 2, okay, is what we're going to get. Value of DF is the number of values that are free to vary. Okay, so basically just remember it's always -1. Okay, reject HO if the p-value is less than or equal to A. So in this inequality here, we've got less than or equal to 0.05. So we're going to go through and calculate this and see what we come up with. Okay, so we pull up our graphing calculator and we're going to start entering our data in. Okay, so now this is a little different when we get into chi-squared. Chi-squared, what we want to do is we want to go now into stat, and we're going to actually edit our data. So we're going to do edit, and it's going to give us some lists, possibly already some stuff in there. So if there is, you just highlight the list, hit clear, and once you go down back into the list, it should be all cleared out. Okay, so the first list is what we call the observed list. So that's what happened. That's what that's how many of each album were bought. Okay, so let's see. Last week 70 of Wayne's, so we're gonna have Wayne be the first one here, and then 72 of Wally's albums were purchased, and then 104 of Bertha's albums were purchased. Okay, now this next one over here is if this is all going to be if it's all going to fit this HO, meaning that 27% of them were Wayne, 31% were Wally, and 42% was Bertha, then what we have to do is we're going to actually go through and calculate what each of these, this is what we call the expected. So this list 2 is going to be the expected value. Okay, so let's maybe even write that down here somewhere so we know. So list 1, or when we look at it in the calculator, it looks like that. List 1 is observed. And then L2 is going to be expected. That's what we should expect to happen. Okay, so in order to figure out the expected, we got to figure out how many total there were sold. So 70, 72, and 104. So in this case, we're going to do 70, 72, and 104. Gives us 246 total albums were purchased. Okay, so now normally for Wayne, we expect 27% of those 246 to be purchased. So you can actually go through ahead of time and do the math, or you can actually just do the math right here in the list. At least that's what I was able to do earlier. So I'm going to do 246 times 0.27, and it'll actually give us the value. So we would expect 66.42 2 about to happen. And then we are going to do our total 246 times, let's see, 0.31. Okay, so we'd expect about 76.26. And then for Bertha, we are going to do 246. I hope I did 246 in the previous one. I think I did. 246 times 0.42, because that's the probability for Bertha. Okay, and I'm just going to double check this one. I can't remember. I'm just going to type it in again just to make sure. 246 times 0.31. Okay, I think I had that right the first time. So these are our two lists. Again, what we observed, what the data said, and then what we would expect if these percentages are to hold true. Okay? Next, we're going to go through and see what it tells us and fill this out. But first, let's take a quick little comedy break.
Time in my life where I see a walker without the tennis balls on the bottom. Honestly, all the technology we have nowadays, could we please slow down production on the next iPhone and just dedicate a couple guys from Apple to work on the tennis ball, on the walker problem we have running rampant in this country?
All right. Okay. We have all of our data in here. So we're going to go back into stat, and we're going to go over to tests, because it's the chi-squared. And we're going to look in here. It's the chi-squared goodness of fit. So first we got to look for the little x going on here. Okay, here we go. We got chi-squared test and chi-squared goodness of fit test. So that's the one we want. Okay. So observed, that's what we put into list 1. Remember that? Observed. And then the expected was in list 2. So we're good there. Now, our degrees of freedom, remember, we have 3 categories. 3 minus the 1 gives us 2. So our degrees of freedom in this case is going to be 2. Push enter, go down to calculate, and we push enter, and up comes all of our magic information here. Calculate the value of the test statistic chi-squared. So that chi-squared is 0.435. 435, okay? And then we're also going to use that all-important p-value, 0.804. So the p-value equals 0.804. So we put 0.804 in here. And it says reject HO if the p-value, 0.804, is less than 0.05. That is not. So we are going to not reject HO, which means that we accept HO, which means that this is relatively close and true to what the percentages are, okay, within a reasonable percentage here, okay? So we would go with that the probability of Wayne Cochran is about approximately 27%. Wally Whiten is 31%, and Aunt Bertha is at about 42% of the sales. Okay? So we can simply write it like that. It says write your conclusion in a sentence. We could write it all out. Probability of Wayne Cochran, 27%, or approximately. That's why I did the little squiggly lines instead of the equal sign. So I just didn't write it out in a complete sentence like I should have, but that at least gives you the idea. Okay? Okay, that's all we have for the first half of this. We're going to come back and do a second video to explain more of this. If you have any questions on this stuff, please feel free to ask. Thanks.